Good morning to all. The first unit is matrices and calculus. In this unit, we see about the topic eigenvalues and eigenvector of a real matrix, characteristic equation, properties of eigenvalues and eigenvectors, Hamilton theorem, diagonalization of matrices, reduction of a quadratic form to a canonical form by orthogonal transformation, nature of a quadratic form. The first topic we see is a characteristic equation. So for a given matrix, we find the characteristic equation. We use the formula determinant of A minus lambda I is equal to 0. Here A is nothing but the given matrix, lambda may be any scalar, and I is nothing but the unit matrix. So for example, now consider the matrix A equal to 1, minus 1, 0, 1. This is a 2 cross 2 matrix. The characteristic equation is nothing but determinant of A minus lambda I is equal to 0. So I am writing in the determinant form 1 minus lambda minus 1, 0, 1 minus lambda is equal to 0. Now I am expanding this one is the determinant 1 minus lambda the whole square into 0. So 0 we get the characteristic equation. Now we find the characteristic equation of the matrix. So we will use the formula determinant of A minus lambda I is equal to 0. Here A is nothing but the given matrix, lambda is any scalar, I is nothing but the unit matrix. For example, I am considering A equal to 1, minus 1, 0, 1. This is a 2 cross 2 matrix. The characteristic equation is A minus lambda I is equal to 0. Now I write the 1 minus lambda minus 1, 0, 1 minus lambda equal to 0. Now I expand this determinant 1 minus lambda the whole square, 0 into minus 1 is 0, which is equal to 0. Now 1 minus lambda square is equal to 0. This is A minus B the whole square. So lambda square minus 2 lambda plus 1 equal to 0. This is the characteristic equation of the matrix. For consider another example, my A is 1, 2, 3, 4. This is again our 2 cross 2 matrix. For the characteristic equation is A minus lambda is equal to 0. Now I 1 minus lambda, 2 minus 3, 4 minus lambda is equal to 0. Now I expand this determinant 1 minus lambda into 4 minus lambda. Again 3 minus 3 into 2, 6, which is equal to 0. Now I am multiplying inside, I am getting lambda square minus 5 lambda plus 10 equal to 0. This is the characteristic equation of the matrix. This is the one form. Another method is the characteristic equation for any 3 cross 3 matrix. We write lambda cube minus A1 lambda square plus A2 lambda minus A3 is equal to 0. This is the another method. Here our A1 is nothing but the sum of the leading diagonal elements, and A2 is nothing but the sum of the minor of the leading diagonal elements, and A3 is nothing but the determinant of the given matrix. For example, now we consider the matrix A equal to minus 2, 2, minus 3, 2, 1, minus 6, minus 1, minus 2, 0. This is a 3 cross 3 matrix. For the 3 cross 3 matrix, I am considering A1 is nothing but the sum of the leading diagonal element. Sum of the leading diagonal element means minus 2, 1, minus 2, 1, 0. So I am adding these two elements. I am getting minus 1. And A2 is nothing but the sum of the minor of the leading diagonal elements. So sum of the minor of the leading diagonal elements means first we see this is our A11 element. We omit this row and this column, we get 1, minus 6, minus 2, 0. And the second one, the diagonal is 1. So we will omit the corresponding row and the column, we get minus 2, minus 3, minus 1, 0. And third one, this element, we omit corresponding row and the column, we get minus 2, 1, 2, 2, 1. So now I am expanding this determinant to this one. My A2 is nothing but minus 21. And A3 is nothing but the product of determinant of the matrix. So I am expanding this determinant, I am getting 45. The general equation of the characteristic equation is lambda cube plus A1 lambda square minus A2 lambda square minus A3 lambda equal to 0. I am putting all the values, then I get the corresponding characteristic equation is lambda cube plus lambda square minus 21 lambda minus 45 is equal to 0.